This video demonstrates how vortex rings reflect under the free surface of water. Here is the aquarium setup. These are turbulent vortex rings being shot horizontally at about 1 meter per second. That was 3 quick shots in real time, and now we're seeing 3 shots in slow motion. What you see, however, is not the water rings themselves, but air bubbles trapped in the water rings. These bubbles are captured by the ring as it is formed by the ring gun. After the bubbles are captured, they are simply carried along with the ring. Here is a close-up of the ring gun in action. The rings are formed by pulses of compressed air, about 100 pounds per square inch. A diaphragm in the ring gun passes the impulse to the water. As the water exits the gun, the ring is formed just outside the opening. The bubbles in front of the gun are picked up in the process. These are shots of the process at varying rates of slow motion, 8 times, 16 times, and 32 times. Now to the reflection. First we shoot rings at a shallow angle to the surface. 3 quick shots in real time, and then 3 shots in slow motion. Notice the small wave on the surface. This disturbance in the surface seems disproportionately small considering the energy carried by the ring. What do you think? After watching the whole video, go back and review the real-time shots. Here is a slow motion close-up of the reflection from above the surface, and then a slow motion close-up of the reflection from below the surface. Now we are going to shoot rings at a much steeper angle. As before, 3 shots in real time and then 3 shots in slow motion. The surface wave is now much larger. The turbulence of the ring and the surface tension of the surface make the wave even more interesting. Still, it seems to me that this surface disturbance is small relative to the energy and momentum carried by the ring. Again, here are close-ups of the reflection from above and then from below the surface. One cannot help but be amazed at how such high-energy vortex rings so effortlessly reflect at the free surface. For each ring, however, there is a critical angle beyond which it will not reflect. Observe what happens when the angle is too steep. Welcome to Vortex Rings Part 2. This video demonstrates how vortex rings refract at a fluid interface. Here is the setup. These are turbulent water rings being shot up into a tank of floating solvent. That was 3 quick shots in real time, and now 3 shots in slow motion. There is a fluid exchange which occurs after the ring is in the solvent. The denser water is ejected from the ring as the lighter solvent is pulled into the ring. Notice how the ring flashes to white. You can see a wake of ejected water. We end up with a ring which is a mixture of water and solvent. Now a time lapse to show the path of the ring. Here are some slow motion close-ups of the motions through the interface. Now we will shoot rings at a shallower angle to the interface. As before, 3 shots in real time and then 3 shots in slow motion. This will also be followed by slow motion close-ups and even slower motion close-ups. Another time lapse to show the refraction. Now the run of slow motion close-ups. In these next few slow motion clips, the rings are shot at an angle to the interface which causes them to refract parallel to the interface. At angles shallower than this critical angle, the rings will simply reflect off of the interface and pass back into the water below. The result is a stable solvent ring in the water. Notice how the solvent is captured in the process. If the angle is even shallower, the ring will reflect off of the interface without capturing solvent. In this last clip, you see refraction and reflection. The angle is steep, and so the ring refracts at the interface, reflects at the solvent surface, and then refracts back into the water as a solvent ring. Well, this is the last clip. Thank you for watching Vortex Rings, Part 2. Welcome to Vortex Rings, Part 3. This is a very short video showing how vortex rings diffract as they pass near a solid object. We simply shoot rings past a glass surface. That was 3 normal shots and now 3 slow motion shots. A time lapse to show the diffraction. Thank you for watching Vortex Rings, Part 3. Welcome to Vortex Rings, Part 4. This is a video showing how vortex rings can spin and carry angular momentum. We shoot 3 rings in real time, just so you can remember how fast they really go. And now we are shooting 3 in slow motion. These are normal, non-spinning rings. The ring gun is modified to swirl the water near the opening where the rings are created. The amount of this swirl can be varied. A small amount of swirl creates rings which spin slowly. Here are 3 slow spinning rings. We can increase the swirl and get rings which spin faster. Here are 3 faster spinning rings. Continuing to increase this swirl, however, does not produce faster spin. More swirl at the ring gun does not increase the spin rate of the ring created. These rings seem to have only 2 possible spin states. In all the rings that I have created, I have only ever seen 2 distinct rates of spin. It is a mystery to me why this spin should be, dare I say it, quantized. We will end Part 4 with a time lapse which shows the helicity of the core streamlines. Thanks for watching.